Hello, my name is Spencer Eric Pitcher. Thank you for joining me in my presentation for my development project, the conversion of manned aircraft into expendable autonomous aerial systems for the suppression of enemy air defense missions. If you want to pause the video and pull up a copy of my presentation if you can't see it on the screen. If not, we can go ahead. The purpose of this paper is to outline an autonomous drop-in package for a manned aircraft to be used in the suppression of enemy air defense mission set, which will keep pilots out of harm's way. Here's a quick overview of my presentation. I'm going to go into the perceived need of this autonomous system, the sociotechnology that I found when I was researching my paper, as well as the inspiration of my paper, the mission of suppression of enemy air defenses, the objective and mission requirements for this developmental project, the design overview and system limitations, the conclusion of my developmental project as to why we need this system, a summary of my presentation, my list of references for both my developmental project and my presentation, and if you have any questions at the end. There are three factors as to why this autonomous system is required that culminates in the need for converting manned aircraft into autonomous aerial systems. The first is the mission of the suppression of enemy air defenses, or SEAD missions, is that it is prohibitively dangerous. The first aspect of a SEAD mission is for a pilot to fly into enemy territory and into enemy air defenses, which is a very dangerous mission, and is one of the three reasons why it is a type of mission to automate. Missions that can be automated that are dull, dirty, or dangerous are perfect missions for an autonomous system. The second one is current unmanned systems are not designed for this type of mission and are too costly if one is lost. If you remember back to June of 2019, 2 U.S. military unmanned aerial systems were shot down using advanced air defenses. The first one was an MQ-9 Reaper, and the second was an RQ-4 Global Hawk. Combined, the total loss was over $194 million. That's an extremely high amount of money for a mission set that can be expected to lose aircraft. The third aspect is that higher military officials do not believe that stealth will be as effective in the future as we currently perceive it now. With the advancement of radar and computing can make that effectiveness of stealth null and void. With all three of these aspects, the dangerous aspect, which requires an autonomous system, current systems are too expensive to be in a role that can be expected to be used as an expendable aircraft, and lead to the loss of the system, which rolls into the need for a cheap aircraft, and that does not have stealth because that technology might not be useful in the future. The associated technology, when I was going through this project, I found two aspects that might play a role in my developmental project. The first was the QF-16, which is an F-16 fighter aircraft which has been converted to be a remotely piloted aircraft to be used as an aerial target drone. The conversion package costs around $1.14 million per plane, which compared to the amount lost in June of 2019 with the 2 downed unmanned aerial vehicles is much less expensive. The second aspect, which gave me the idea for this developmental project, was the use of the Chinese People Liberation Army's Air Force conversion of 1950s era J-6 fighter aircraft to be used in the SEAD mission. But it is speculated that they don't have any autonomy, that they're just designed to take off, fly into enemy air defenses and to be purposely shot down to expend all the enemy's ordnance. But this mission still leaves the enemy positions available to be used again. The mission of suppression of enemy air defenses was developed during the Vietnam conflict, where specially trained pilots would fly into enemy air defenses to be purposely targeted and fired upon. The pilot would then dodge the incoming fire to then destroy that enemy position. Because part of this mission can entail the aircraft being shot at, the pilot is put in harm's way, which is why this mission can be made into one that an autonomous system can take over. In my slide you can see the F-16 fighter aircraft, which is currently being used by the Wild Weasels out of Shaw Air Force Base, which the Wild Weasels take on the mission of SEAD in today's Air Force. So the objective and mission requirements is quite simple. It must be made before the design can even be developed. The system must have autonomous functionality to start with. It must be able to take off and land, fly in formation, follow waypoint guidance, all the while maintaining the original aircraft's flight characteristics such as maneuverability, speed, and payloads. It must also be able to communicate and coordinate with the other aircraft, not only autonomous aircraft, but manned aircraft that are in the area. So for example, if there's an opening in the formation, whether that craft has been shot down or due to terrain availability, the system must be able to autonomously figure out, oh, alright, we need to move an aircraft here to plug in the gap, to make sure there is a complete field of fire over the entire mission area. And if one aircraft is targeted or fired upon by enemy air defenses, the network of aircraft will autonomously figure out, alright, this aircraft is being targeted, and it'll select another aircraft or that aircraft to target and fire at the enemy position to destroy it. Design overview and system limitations. So for my developmental project, I decided to choose the F-16 fighter aircraft, which is currently being used with the QF-16. It is a fly-by-wire aircraft, which is very important for this developmental project, because the fly-by-wire system uses a computer for controlling of the control surfaces, and being able to plug the autonomous system into the computer will make it a lot easier to add in the autonomous system. It must still be able to function just as the original airframe design, which the F-16 is designed to be an extremely maneuverable aircraft. So for the SEAD mission, the F-16 will be able to not only fly maneuverably to dodge incoming enemy fire, but be able to fire upon the enemy position. And must be able to perform mission collaboration with swarming. Just as I mentioned in the previous slide, all the aerial systems must be able to coordinate with one another and be able to know what's going on with the other aircraft. For my system limitations, there are three aspects that I found. The first is the availability of swarming technology. Swarming technology is progressing at a good pace, but it's still in its infancy. In late 2018, DARPA, or the Defense Advanced Research Projects Agency, did a test with both manned and simulated aircraft to perform missions where they all worked in collaboration to destroy a target together. Now, while this included simulated autonomous aircraft, it still requires a lot more work in order to integrate actual autonomous aircraft into a manned mission. For the hardware technology, it's very close. It just needs to be developed a little bit more, where the hardware of like the QF-16, can be added in and implemented with autonomous functionality and swarming technology. The biggest of the three system limitations is the decision-making and ethical limitations of this design. The mission for these systems is to seek out and destroy targets, but the possibility of destruction of targets includes the possibility of loss of life. With that possibility, if there's ever a mistake, the fault would not be from human error, but an error of programming, which would fall on the programmer, not a trained pilot, when it comes to who's to blame. Since the introduction of aircraft into combat, there's been a need to protect the pilots who fly those aircraft. The mission of SEAD directly puts pilots into harm's way, which, because it is a dangerous mission, it is a perfect mission to automate. With the use of similar technology used today, an effective autonomous package can be developed to convert manned aircraft into expendable autonomous systems for the suppression of enemy air defenses. In our presentation, I went over the perceived need of why we need a drop-in autonomous package for manned aircraft, the associated technology that I found when researching this developmental project, as well as the inspiration for my developmental project, the mission of the suppression of enemy air defenses, and how it's a dangerous mission, the objective and mission requirements for this developmental project, design overview and system limitations, my conclusion of why we need this in order to keep pilots out of harm's way. Next will be my references and questions. Here are my references. Do you have any questions? Thank you so much for joining me. Please reach out to me via email or in the discussion posts, and I'd be glad to answer anything. Thank you.